Thank you for joining me for this screencast on writing electron configurations using the periodic table. In the last video in the playlist, we looked at or learned how to write electron configurations using the orbital diagram. And this is an example of the orbital diagram here. Now, what if you were in a situation or working out a problem where you needed to know the electron configuration and you don't have an orbital diagram handy? Or perhaps you're just tired of filling out these orbital diagrams because they can be time consuming and they can be tedious to do. The good news is that it is fairly easy to figure out the electron configuration of an element without an orbital diagram. In fact, you can do it from just the periodic table. Now, in order to use the periodic table to find the electron configuration of an element, we have to translate the periodic table a little bit. And that's what this slide here is showing. Okay, it's separating the periodic table into 4 blocks corresponding to the 4 types of sublevels. We have the S block, first 2 columns on the left are the S block. We have the D block, the portion in blue corresponding to the transition metals. We have the P block, this region in orange on the right side of the periodic table. And we have the F block, the region down below corresponding to the inner transition metals in yellow. Okay, I want to point out a couple of things on this periodic table before we go on and look at our examples. The first thing that I wanted to point out is with the S block and the P block, the energy level connected with the S and P block corresponds to the exact same period or row of the periodic table. So like for example, the 1s block is located on the first period of the periodic table. The 2s and 2p blocks are located on the second period. The 3s and the 3p blocks are located on the third period. And the 5s and the 5p blocks are located on the fifth period of the periodic table. The thing that's different, the thing that I'm calling your attention to, is with the D block, okay, and really the F block too, but we're going to talk just about the D block. Okay, so the D block, notice that the energy level, in this case it's 3D, this first row of the D block is labeled 3D. However, the 3D area of the D block is not actually on the third period of the periodic table. It's on the 1, 2, 3, 4. It's on the fourth period of the periodic table. Okay. Likewise, the 4D row of the D block is not actually located on the fourth period of the periodic table. It's actually located on the fifth. Right, so here's the first, second, third, fourth, and fifth periods on the periodic table. Okay, so the point is the energy level associated with the D block is always 1 less than the period of the periodic table. Okay, with that in mind, let's go ahead and look at an example of how we can find the electron configuration of an element using the periodic table. Okay, so for this example, we're looking at aluminum. Okay, the first thing you're going to want to do is go to the periodic table and find the box for the element that we're interested in. In this case, we're interested in the element aluminum. Okay, now we're going to go to this translated table and I'm going to highlight the box for aluminum. Okay, this is where we're wanting to end to get to. Okay, whenever you are using the periodic table to find the electron configuration, you're going to read the periodic table kind of like you would read a book. When you read the page of a book, you always start at the upper left page of the book. And then you read to the right on the line until you get to the end of the line. And then you go down a line and all the way to the left, and you continue on. Well, it's the same basic way with this periodic table when you're finding the electron configurations. Okay, so whenever you're doing this, you always want to start with hydrogen's box. Okay, so we're starting at hydrogen, and we're basically going to read through all of the boxes until we get to the one that we're interested in this case, the one I've highlighted in red, aluminum's box. Okay, so starting at hydrogen, to get to aluminum's box, we have to move through the 1s1 box over through the 1s2 box. Okay, so as we get to the end of each row, I'm gonna just make a note of where we're at. Okay, after I've passed through the 1s2 box, just like reading a book, I'm gonna go down a line into the all the way to the left. Okay, now to get to my desired element, which is aluminum, I've got to continue moving through the 2s1 and the 2s2 boxes. Okay, so we've passed through the 2s2. We're still not to aluminum, so continuing on. Now enter the 2p, and I've got to pass through all of these boxes to get to aluminum. Okay, and that's 2p, 1, 2, 3, 4, 5, 6. We got 2p6. Okay, but I'm still not at aluminum. So just like reading a book, I'm going to go down a line and all the way over. Okay, I would then enter the 3s. I've got to pass through the 3s1 and 3s2 boxes. I'm still not to aluminum yet, but I'm getting close. So I need to pass through the 3s2. Okay, continuing to read over. And hey, I've now entered my desired box. So I would stop there, but I did need to enter the first box of the 3p sublevel. So I'm going to label this as 3p1. Okay, so if I go back to my this slide where aluminum was listed, I now know my full electron configuration for aluminum. Okay, we'll go ahead and write that here. We got 1s2, 2s2, 2p6, 3s2, 3p1. Okay, and that's the full electron configuration for aluminum. Now, to find the noble gas electron configuration, okay, what you want to do is go back to the periodic table, and you want to find the noble gas that comes just before the element you're interested in. In this case, I'm interested in aluminum. Aluminum is element number 13, and the noble gas that comes just before aluminum would be neon, which is element 10. Okay, so for the noble gas configuration, what I'm going to do is I'm going to put neon in brackets because that's the noble gas that comes just before aluminum. And what that means is now when I'm doing my electron configuration for aluminum, I'm basically starting right after neon. Okay, so what comes next after neon? Well, I'm going to go down a line and all the way over to the left. We got 3s2 all the way over to the 3p, 3p1. Okay, so after my neon in brackets, I would then write 3s2, 3p1. Okay, now what the neon in brackets means is it's basically a placeholder for all of this stuff right here. Okay, the 1s2, 2s2, 2p6, that would be the electron configuration for neon. Again, the noble gas configuration is a shortcut or a shorthand way of doing these electron configurations. Let's do another one, phosphorus. First thing I'm going to do is I'm going to go up to the periodic table and I'm going to find the box for phosphorus. Okay, it looks like it's on the third period, 1, 2, 3 spaces in. And so that's this box right here. Okay. Remember, we always start up at hydrogen. And so let's read through all of these element boxes together, starting with hydrogen, until we get to our desired box, which is the box for phosphorus. Okay, starting at hydrogen, we're going to go 1s1, 1s2. Following the 1s2, we would enter the 2s2. Okay, but we're not to our desired box yet, so we keep on going. We enter the 2p, and we would need to pass through the entire 2p section in order to get to our element phosphorus. So that's 2p6. Okay, but we're still not there. So we go down a row all the way to the left. We enter the 3s, pass all the way through. That's 3s2. And we're still not there, so we keep on going. We enter the 3p, and we then go 1, 2, 3 spaces over. So that would be 3p3. Okay, so that's the electron configuration for phosphorus. Now let's find the noble gas electron configuration. So phosphorus is here, element 15. I need to find the noble gas that comes just before my desired element, phosphorus. And it looks like it's element 10, neon. Neon is the noble gas. Okay, so if I wanted to write the noble gas configuration for phosphorus, I would start by putting the element neon in brackets. So that's assuming then that I'm starting right after this box here. So down a row all the way to the left, we enter the 3s. But in order to get to our desired element, we need to pass through both 3s boxes, so 3s2, all the way over into the 3p, and it's 1, 2, 3 spaces over 3p3. Okay, so again, remember the noble gas configuration is shorthand. And so by putting neon in brackets, that's basically a placeholder for all of this stuff in the brackets, 1s2, 2s2, 2p6. Moving on to the final example. It looks like we are working with selenium this time. Okay, so the first thing that I'm going to do is go to the periodic table and I'm going to find the element selenium. It's element 34. Okay, it looks like selenium is on the fourth period and it's underneath where oxygen would be. So if I come over to this periodic table here, I'm going to go find selenium's box. Okay, on the fourth period underneath where oxygen would be. So that would be right here. This is the box for selenium. Okay, we're going to read through all of the boxes, starting with hydrogen. So here we go. Okay, 1s1, 1s2. Okay, after the 1s2, we enter 2s, pass all the way through it for 2s2. Still not to selenium. So then we enter 2p and we would need to pass all the way through the 2p. That's going to be 2p6. After the 2p, we enter the 3s, and we would need to pass through that. So we get 3s2, and we keep going. We enter the 3p, and we pass all the way through the 3p. So that's 3p6. After 3p, we enter 4s. We need to pass all the way through it for 4s2. But we're still not to the box for selenium. So now we enter the 3D. We would need to pass through all of the element boxes in the 3D area. So that's 10, 3D 10. Following the 3D, we now enter the 4P. And we would need to come over 1, 2, 3, 4 boxes over for 4P4. Okay, and that would be the electron configuration for the element selenium. Let's go ahead and find the noble gas configuration for selenium. Okay, so we need to find the noble gas that comes just before selenium, and it looks like that would be argon. All right, so argon is going to be this box here. Okay, so this is assuming then noble gas configuration is assuming that we've already passed all the way through argon's place, and we would continue from there. So going down and all the way over from argon, we would enter 4s and pass through. So that'd be 4s2. Then we enter the 3d and pass all the way through 3d10. And then we enter the 4p. We go 4 spaces over for 4p4. Okay, so argon being in brackets here, if we go up to our full electron configuration, the argon in brackets is a placeholder for all of the stuff up to 3p6. Okay, and then what comes after is what we have after down here. All right, so now it's time for you to pause the video and work out these 3 practice problems here. Check for understanding, make sure you got it. Okay, write the full electron configuration for potassium, nickel, and strontium, as well as the noble gas configurations. After you've worked those out, go ahead and continue with the video where you'll be able to check your answers and make sure you got it. Now that you've had a chance to work out these problems, please pause the video again and check your work. All right, that's all for this tutorial. Thank you for sticking with me all the way till the end. If you have any questions or comments, please leave them in the comments area below. And I hope this was helpful. Please take care.